Hi guys, so today we're going to be looking at this pretty nice limit. We have a fraction, and in the denominator and in the numerator we both have infinite sums. So let's look in detail on them. In the numerator we have 1 plus a squared plus a cubed plus a to the fourth and so on plus a to the n. And the same thing at the denominator but with number b. We also have n approaches to infinity, which means that the sums get only longer and longer. We also have this little detail that the module of a and the module of b are both less than 1, which just means that a and b are bounded in region -1 and 1. Now, this will be important later. Okay, so in order to solve it, we want to get rid of the infinite sums because we don't really have much tools to deal with them. To do this, we're going to look that every next term of the sum is multiplied by number a, right? So we start with 1, multiply by a, get a, multiply by a again to get a squared, and so on, multiply by a n times to get a to the power of n. And the same thing with b. Now we know what this is called. This is called geometric progression, right? And we have the formula for the sum of first n terms of the geometric progression. It goes as follows. So we have b1, which is the first term of the sum, times the fraction 1 minus q to the power of n divided by 1 minus q. So what is q? Q is the number that we multiply each time. So in the first case, q is a, and in the second case, q is just b. b1 in both cases is just 1, because we start at 1. So let's use this formula to rewrite our problem. Don't forget that we have a limit as n approaches infinity of the following. So in the numerator we have b1 is equal to 1, I'm not going to write it, and 1 minus a to the n divided by 1 minus a. So we just substitute q is equal to a. The same thing in the denominator. We have 1 minus b to the n divided by 1 minus b. Okay, now we will now notice that we were left with the following expression where n only goes 2 times, a to the n and b to the n. Let's think what happens to numbers a and b when we raise them to the power of n, which approaches infinity. Because they are in this small region from -1 to 1, if we multiply them by itself, right, they only get smaller and approach 0. Think about the number 1/2. It definitely is in this region, and if we multiply 1/2 by itself, it will only get smaller. So 1/2 times 1/2 is 1/4, right? And so on and so on, 1/8, 1/16, 1/32, and it approaches 0. The same thing here. So we can just ignore these terms because they are equal to 0. And now we get rid of the limit because we don't have n anywhere else. And we are left with the following: 1 minus 1 minus a, 1 divided by 1 minus a, divided by 1, divided by 1 minus b. So now we want to just make this clear and write as the following. We get the fraction 1 minus 1 divided by 1 minus a, divided by the fraction 1 divided by 1 minus b. To do this, we just turn this fraction upside down and multiply by it to get 1 minus b divided by 1 minus a. So I hope that this is clear. And this is pretty much the answer, because we won't make this any simpler. Now, I think that this is pretty nice, that the quotient of two infinite sums that only get longer and longer with n approaching infinity actually converges to a fixed number, which we can calculate if you know a and b. If you also think that this is pretty nice, maybe write about it in the comments. and maybe leave a like, subscribe to channel. Make sure to watch other videos, they are also very interesting. And that's all for today. Bye.